Sounds like some stupid self-help book. The power of I. To the second power is the most important one.
Oh.
Good Lord, in half. You gonna work today? Okay. There we go, buddy. Yeah. Okay. That's an exciting start. Okay, so if you don't turn it all, that's I to the 0. So you're still on 1. You do a quarter turn, now you're at, this is the I axis. So that's like I, it's like negative I. So there's a 2I up here, a 3I, a 4I. So it's kind of like the I axis. So I to the first is I. Do another turn, you end up at negative 1. So I squared is negative 1. If you do another turn, you end up at negative I. So I cubed is negative I. If you do another turn, you end up at 1. So I the fourth is gather 1. And then it repeats, because now you've turned all the way back to where you started. So it really, 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 really is a lot like 1. Negative 1 squared is 1. Negative 1 is negative 1. Negative 1 cubed is negative 1. But this is much simpler. There's only 2 values. Multiply negative 1, you get negative 1. Multiply negative 1, you get 1. Multiply negative 1, you get negative 1. Multiply negative 1, you get 1. Right? So that's easier. So any odd power is negative 1. Any even power is 1. Cool? So what's negative 1 to the 48th power? 1. This guy, since I is a quarter turn, there will be 4 values for that. Same idea, though. Exactly the same idea. Yes?
Did you go over something like on the quiz where it was like the I values? I didn't get that at all.
All right. So on one level, they are just like a variable. They're just like x. Right. They're just another letter. So if I said, what's 8 minus 2i minus 5 minus 3i, what should I do first? Yeah, distribute the negative. So 8 minus 2i minus 5 plus 3i. So now what can I put together?
8 and negative.
Yeah, 8 minus 5 is 3. Negative 2i plus 3i is...
Oh, is that simple?
Yeah, dude. And then... Now, see, that didn't involve any powers of I. So I really could just look at it as a variable. And I do that with I all the time. And then at the end I go, can I do anything? No. If it was I squared, then I can replace it with negative 1 and do more. Right? So now if it was this instead, if I was multiplying these instead of subtracting, 40 minus 24i minus 10i plus 6i squared. Just a southern lawyer. I don't know what. I know me some bird law. Let's see. 40 minus 34i. Is that cool?
Yeah.
What can I do this though? Yeah, this is I squared is negative 1. So then I get 40 minus 6 is 34. That's a neat one. I like that one. 34 minus 34i. Yay. It's just whatever you get. Yes?
You had an example of I to the 25th.
Sure, okay.
Can you explain that?
I to the 25th. So since every fourth starts over, I divide by 4 to take out all those terms. So 25 divided by 4 has remainder what? Yeah, so this is the same thing as I to the first. And what's I to the first? I. That also sounds like a self-help book. I to the first. Be the best I can be. Okay? All right, this is good. So quizzes kind of gauge where you are with your understanding, with you doing the homework. And then after you take a quiz, you go, well, shit, let me get ready for the test. Because tests are heavier weighted. So quizzes, to me, are little gauge points that, and then over here, you're going to have the real, Yes?
When's the next test?
Oh, the final, yeah. Yep. We're done with, little tests. Our next one is a bigger test, yeah. Okay. We still have, 1 or 2 quizzes, maybe 1 quiz, I don't know. Besides this one, maybe. I don't know. We'll see. We'll see if we get another quiz. Okay. Anything else from homework stuff or general questions? Aw, I almost had that. All right, let's take a union break. What are you doing? No, it's not responding to me at all. We're going to be in the green book here in a minute. All right, I'm going to give it a minute. We'll be on the board for a bit. So last time, all right, so let's see. Let's review. This is good. Let's review. Can anybody tell me anything about this? I'm giving a function name. This thing. Anything. I'll take.
Can you make equal to 0?
I mean, you could. But what can you get just by looking at it?
Okay.
Vertex. So the x piece of the vertex is -5, sure. -2, I like it. So that's the vertex. Does it open up or down?
Down.
Opens down. I like it. Okay. Okay, cool. I like it. So of course we did some problems where we put it in this form. It involved completing the square, right? I like it. What's the ultimate shortcut though for finding the vertex? Yeah, so if I have ax squared plus bx plus c, how do I find that guy's vertex? The x piece. What's the shortcut? Negative b over 2a. I like it. And of course you gotta have a y piece. And how do I get the y piece of the vertex? I just plug this in. So you get the y piece. Cool. I mean, that's what you always do. If you know x, you plug it in and you get y. So that's a shortcut to get the vertex. And then physically, what's the vertex mean? If this is me throwing a ball, what would that vertex mean? That is the highest point that the ball hits on its trajectory. I like it. I like it. So if I had like a submarine, I don't know what. Anybody seen that movie, The Meg? No? You haven't seen that? It was really dumb, but oh well, it's fun. So if you go on into the Marianas Trench and you have a submarine and it's following a parabolic path, and you know that there's a certain depth at which that submarine will crush, don't you want to know the lowest point you're going to hit on this path? And if you're going to hit a point below that crush point, you probably want to change your path, right? So it seems like a good thing to be able to figure out. This is one example. Math saving lives. It's the least we could do. Right. So let's do let's see if this guy will turn on now, because I have an example. It would be much easier if I could. Oh, thank you so much. Machines are just asserting their will on us. Okay. Carrie, can you do just the middle one, yeah. Sweet. Did I turn it on? No. It's a good technology day. Please wait. Okay, so this is page 228. Look at number 3. Okay. So, After how many minutes is the maximum? Now, can somebody tell me, how do you know, not just because they're asking, but how do I know there is a maximum to this thing? What part of that tells me there's going to be a maximum? Say again? No. A maximum would mean the parabola opens up or down. Up would mean a minimum. See that? So down is a maximum. Do you see that? There's the top of a hill when it opens down. How do I know it opens down? First number is positive, but is the first number the important number? No. What's the number in front of the squared part? Negative. Shit, so it's opening down. There you go. They just wrote it out of order. Do you guys see that? Right? So it's not just the first number, because I can't just rearrange those and suddenly make the parabola open up. Oh, no, it's the same stupid equation. You guys, is everybody with me? So it opens up, there's going to be a minimum. Opens down, it's going to be a maximum. So it opens down, it makes sense they're asking me for a maximum. Cool. And again, if there's a certain amount that will kill him, and I figure out that this is going to lead to him going above that amount, I probably want to try to give him something, I don't know, something to counteract that, right? I'm like, you're going to die. Let's do something about that. All right. How the shit do I find? All right. What's A? What's A? Yes, negative 0.0002. Because A is always a thing in front of the squared piece. B is always a thing in front of the thing, the X or the T in this case. What's C? 0. There is no C. There's no constant piece. So what's B? Yeah, the only other thing left, 0.06. So how do I find the time at the maximum? What's my little shortcut I can use? Yeah, and in this case, it's not going to be X here. It's going to be what? T. T is acting like X, and T means time. So if I do this, I'm going to figure out at what time this maximum was reached. If you don't have a calculator, you're probably going to freak out a little bit. Get out of there, that stuff. B is 0.06. And A is the 0.0002. Let me show you why you don't need a calculator. You ready? You ready? I move this over 1, 2, 3, 4 times to make it nice, right? All right. And I better do the same thing. Oh, that was negative, wasn't it? Yeah. I better do the same. So you cancel. Better do the same thing up here. 1, 2, 3, 4. So 600. If you do this in your calculator, you're going to get 300. But you can see it right here. Isn't that 300? All right. Let me stop here for a second. I don't know. Did I leave the 2 out? Yes, it totally did. Man, thank you. So this will be a 4 down here. Yes?
That was my question.
Oh, good. All right, thanks, guys. I was so focused on the decimal business, I forgot the poor little 2 dude. What's 600 divided by 4? It's 150. 150 watts. What's T measured in? Not iced tea. What's T measured in? Minutes, right there. T minutes. So this is 150 minutes. How many hours is that? 2.5 hours. I love it. Because 2 hours is 120 minutes, and that's 30 more extra minutes. So it's 2 hours and 2.5 hours. So in 2.5 hours, this guy's going to experience the maximum serum concentration, which hopefully is below the death line or whatever. Right. All right, so know how much time it takes to get to the maximum. So what is the maximum concentration then? What does this formula give me? T is time. What's C? The concentration. Okay, do I know? So how do I find the maximum concentration? Do I know how long it takes to get there? Yeah, T is 150. So what do I do with that shit? I just plug it in. If I know time, I can plug it in to figure out concentration. That's what that formula does. It's a conversion between time and concentration of drug. So you got to plug a 150 in. should be exciting. I don't know if I want to try that one. It's 9 minus. Oh shit. Let me think. Ooh. Nobody's gonna help me? Okay. You're all just like, come on, Matt boy. Alright, let me do it. 4, 1, 2, 1, 2, 3, 4.5. Is it 4.5?
Yeah.
First one is 90. First one is 90.
90? No. 1, 2, 1, 2. It's 9. Totally. 0.06 times 150. Trust me, it's 9. 4.5 what?
Milligrams per liter?
Yes, see? Yeah, the concentration is measured in milligrams per liter. It's just a reading problem, right? So 4.5 milligrams per liter. So for every liter of blood, there's 4.5 milligrams of serum. That's the maximum concentration of drug in the blood system. Blood system, I like that. Bloodstream. Okay. So some of these problems in this section will just give you an equation. You just figure out what B is, figure out what A is, and do the shortcut. Because the whole thing about finding the max or the minimum is finding the vertex. Now, let's do one where they don't give me an equation. I gotta make it. I gotta make the freaking equation. Oh, shit. Like this one. Read through that, see what you think. Previous page, that's 227. Alright, so they were way too nice to you. They gave you the picture, they label it for you. That's a bunch of shit. Alright, now watch. Or don't. Whenever they give you, this is called an optimization problem. You're trying to optimize the area. And let me see if you guys can figure this out. If I used like 400 feet on this side, right? If I used 400 feet here, how long can these be to use all the fence? How much fence is left? If I use 400 feet for that side,
100 feet left.
there's 100 feet left. And how many more fences do you have to set up?
25.
4, so there's 25. So each of these would be 25 feet, right? And then you got the barn here, so you have to put a fence where the barn is. It's already a side there, right? So you're just building this like this and putting it against the barn. So you do end up with 4 walls. This is one of the walls already there. You don't have to use your fencing for it, right? Well, what's the area of this guy? 25 times 400, right? That would be the total area of this, right? Does this have to be 400? I just made that shit up, didn't I? So what we're about to do is, what would these be so that I end up with the most area here? That kind of makes sense. I want my little orcs and trolls and potbelly pigs, whatever the hell I'm going to put in here. I want them to have enough to move around. Have to be, be happy. So this is just a concrete example of what could happen. I don't know what the hell is going to happen. They're always going to tell me something, and then they're going to ask me something. If you do this for yourself, these problems are so much easier. What do they just tell me? Just give to me. They just give it to me. Like, no guessing. Yeah.
50 feet of fencing.
500.
Oh, 500, yeah.
Yeah. So they tell me I got 500 feet of fencing. 500 feet. How does that relate to an equation? What does that relate to this geometrically? What's 500 feet? It's not really a perimeter, right? Because perimeter would just be concerned about outside. I also have to put fencing here and here. So how many Y walls do I have to put up? 1. Do you see that? Plus, how many X walls do I have to put up? 4. So I got to put up this wall and these 4 walls, and I'm going to use, and they have to equal 500 if I want to use all the fencing, right? So it's sort of like perimeter, except I got to include the middle because I got to put an actual fence there. So I'm going to use the 500 feet of fencing to set up this wall and these walls. That's what they tell you. Now, what do they ask me to do?
Find the dimensions of X and Y. That back to houses.
Area. I love it. So the area is what they want me to work with. And what's the formula for the area of this? Don't overthink it. I kind of gave it away earlier if you were paying attention. What's the area of this rectangle? Yeah. So it's just XY. I like it. Stay with me now, come on. Can you see how you can solve this for Y? This is a substitution problem. They gave me 2 things. They gave me information and they asked me about something. Tell me, ask me. But now there's 2 equations here. Can't I use substitution? Can I solve this for Y? Plug it in, do that. Solve this one for Y. And then plug what you get in here, because then you'll know what Y is in terms of X. Solve this one for Y. Plug it in here. How do you solve this for Y? What do you do? No. How do you mean? How do you get Y by itself? Solve for Y.
Or you put minus 4.
Yes, subtract 4x. That's the only thing that's with the Y. So you go Y is 500 minus 4x. So I know that's true. I know Y is 500 minus 4x. So what can I put right here instead of Y? I could put 500 minus 4x there, right? Do you guys remember substitution method? Remember that's actually nice, right? So these kind of problems will give you 2 equations to work with. An equation that relates to what they just tell me, and an equation that relates to what they're asking me. So I can plug that in here. What I get, area is x times, bless you. Now, when I multiply that through, what kind of thing I'm going to end up with? When I multiply that x through, what kind of thing is this? I love you guys. You guys are like, what the shit does he want me to say? It's a purple equation, dude. No. What kind of thing is this? If I graphed it, it would look like what? A parabola. What kind of parabola? Down. I love it. I see it in the back. I see somebody going like that. Or they might have just been waving to somebody. I don't know. These are not the problems you were looking for. Do you see how we created a quadratic form, a parabola, right? Can I find, and then where is the maximum going to be? Why is this going to have a maximum? Because it opens down. Do you see how that relates? Maximize. Oh shit, the math better lead me to a freaking parabola so I can find the vertex. So they're going to tell you something. They're going to ask you something. You solve what they tell you to plug it into what they ask you, and when you do it, you got to get a parabola. How do I find this guy's vertex? What's B? What's A? What's B? 500. I love it. And what's A? Negative 4. So how do I find the x value of the vertex? Negative B over twice A. Yeah, 62 and a half. Yeah, what's it going to be?
Square feet.
Feet, not square feet. Be careful, because this is just one side. When you multiply x times y, then you get square feet. But this is just feet. How do I figure out? So that this side is 62.5 feet. How do I figure out this side? If I only had an equation for y.
Oh, plug it into the.
Oh shit! I have an equation for y. Because I know x, don't I? So how do I get y? I plug the thing in. So 4 times 62.5 is 250. 500 minus 250 is 250. You guys have really enjoyed that, I can tell. The minute we start doing anything word problem-y, you guys kind of give up. But if you start to break it down, here's the problem. You guys, for some reason, I think students think they're supposed to read through it and just know exactly what to write. Holy shit. Nobody can do that shit. You've got to come up with a way to look at it to break it down. Okay, what do they tell me? Focus entirely on what they tell you. What do they ask me? Read through what they ask you. Oh, area. They're asking me something about the area. What's the formula for the area in this situation? Let me write that down. Then you work with those two. Just solve one, plug it in the other, dude, and see what happens. For us, it's going to have to always come out to be a parabola. In calculus, you can deal with anything. That's good for them, right? For us, we need a parabola. It's the only one we know how to find the max or the min. Okay. What's the area of the one we just found? What is that area? 250 times this. I don't know. All right, so the max area was 16,000? 15,625. Real quick, what's the area of this one that I just kind of made up? 400 times 25 is actually 10,000. So see, I just made this up. It's 10,000 area, but the maximum area is 15,625. And I want you to really think about this. I use the same amount of fence in each of these. Right? I mean, this is a very basic idea that you guys don't really think about much, but if I have a certain amount of stuff, I can orient it in a way to get the biggest area possible. If I just pick away, I'm probably not going to get the biggest area. So I have the same amount of material, but 5,625 more square feet than I did just picking away. Right? That's, you know, my poor little pot-bellied pigs are like, the neighbor used math, you jackass. And I'm all like, I can't move around, we're shit. All right. No? Okay. Let's see. Let's try this one. Look at number 4. Read through number 4 and see if you can do anything. This is very similar to the one we just did. But you have to draw your own picture. So the one we just did with the barn was nice because I gave you a picture. It already labeled the stuff. Now you just have to label this stuff. What do you want to label this side?
Y.
I like. Makes sense because that's like the y-axis, right? What are you going to label this side then? W. No. X. So one side is formed by the shoreline. Okay, I like it. So you would have to be able to create this picture yourself, right? So what is it that they tell me? Just give me straight up.
That you have 200 meters.
200 meters. And what am I going to use at 200 meters to create?
A rectangle.
Yes. So in mathish, what does 200 go into? It goes into this, right? So what is that in math? What is all the way around this?
2yx.
2i?
X.
No.
2x.
No. Plus x, right? How'd you get 2y? Because y plus x. 2y plus x. This is just a straight up, this is not an area we're doing, right? We lay it down here, we lay this down here, we lay this down here. Bam. 2y plus x. I like it. And what is it they asked me for? Not surprisingly, they asked me for maximum area. So what's the area of this guy? Again, it's the same thing. What's the area of this? What's the area of this? X times y. All right, so see if you can finish it out. Which letter would you solve for now? Which is the smarter letter to solve for? X. Why? Because this has got to do how we make fractions if I solve for y. I don't want to do that. Let me solve for x. Plug it in, see how far you can make it. Catch up to you guys. Now, of course, the same idea. The maximum of this shape is parabolic. So we know how to find that maximum. If it wasn't parabolic, we'd be sort of screwed. But it is parabolic. So in this case, it'll be y equals, what's b? 200. Over twice, what's a? What's a? Little a. Negative 2, right? So this would be 200 divided by 4 is? 50. 50 what? Good. 50 meters. So what's x? So y is 50. How do I get x? If only I had an equation. Oh yeah, sure. What's 200 minus twice 50? 200 minus 100. So x is 100 meters. So that makes the maximum area. What would that area be? Did I ask that here? No. But what would that area be? 50 times 100. 5 times 1 is 5. 1, 2, 3 zeros. So 5,000. That would be the maximum area, square meters. Now watch. If let me do this again. If I were to just guess, let's say I make this side, I don't know, 140. How much do I have left? 60. So that would mean these two sides would be 30 each, right? What would the area of this be? What's 30 times 140? I'll tell you. 4,200. Any other way you set it up? Do you guys see how I got those numbers? I just made up a number for this, and I saw how much was left, and I put them on the other sides. Anything else you just kind of make up that leads you to 200 meters is going to be less than 5,000 square meters. That's the only way. This is the only dimensions that will give me the most area. Any other dimensions? Less area. And you want the kids to have more area to splash around in and not get eaten by megalodons or piranhas or whatever horror movie they're in. All right. You guys seem less than thrilled about everything. I think we'll stop there. So next time we'll get into chapter 12, or 12, right? Yes. Yep, next time we'll get into chapter 12. And then we'll see how much time you got to get through whatever for the semester.
This is something.
Yeah.
I forgot how we calculate